So, basic question, but what makes data big? I mean, this is a big data course after all. Traditionally, big data has been defined in terms of the three V's, and sort of they've added two V's since then. The first V is maybe what you think of when you hear big data, and that is volume. Data is big if there's a lot of it. Um, in particular, data sets these days are often too big to store on a computer, like thousands of terabytes of data. So we have to deal with that somehow. Then the second V, velocity. Um, Velocity in this context means that the data is constantly updating. Pretty straightforward. You are a website admin and you're tracking the interactions that people have with your website, all of the links that anyone clicks. Well, if your website is super popular, like if it's Amazon or Wikipedia or whatever, maybe you're getting 100 million new observations every day. So you have to deal with high velocity data. And the third of the original three V's is variety. Maybe you've got a bunch of different types of data. So you've got images and text files and movie files and music files all being stored together. So these are the original three V's. Since then, we've gotten veracity. And veracity is just, well, is your data reliable? So this isn't a big data specific problem at all. We talked about this a lot back in 301. But of course, the bigger the data set, the harder it is to verify anything about it. I mean, because if your data set is 500 terabytes or whatever, are you going I mean, are you going to inspect it manually? What are you going to do? So I mean, this is something you always have to worry about, but it's something that big data makes worse. And finally, we have value. So the idea behind, I mean, obviously you hope your data is valuable. Otherwise, you wouldn't be looking at it. But I think sort of the specific issue here is there's, let me move that so it's not being, heaven's sake. There's There's very valuable data in the data set, but it's being drowned out by a huge number of less valuable observations, is sort of the issue here. So none of these inherently are problematic. I mean, well, volume, I guess, is a little inherently problematic if your data doesn't fit on your computer, you need a way around that. But what I really mean is like things like velocity. You can have your data updating and not need some kind of specialized big data algorithm to deal with it. I mean, think back to Math 301. That's what dashboards are for, right? You've got data and it updates in real time. You know, variety. There's nothing inherently problematic about having different types of data. We're perfectly used to having categorical and numerical data mixed together, for example. But if you have enough of these, and if they're extreme enough, then eventually your traditional modes of investigation do break down. And big data, a course like this is asking, okay, so what do you do when your traditional modes of inquiry are no longer working? And I mean, the phrase that you've probably heard, even if you're not quite sure what it is machine learning. So in this course, we'll talk about machine learning and other methods we can use when the Python we learned back in 301 is no longer cutting it.